Hello friends, welcome to another video lecture of Biovision Academy. And students, now we are going to discuss about non-competitive inhibition. Okay? Students, non-competitive inhibition is that kind of enzymatic inhibition in which both inhibitor and substrate bind simultaneously with the enzyme molecule. Okay, it means the binding site of inhibitor and the binding site of substrate is different. Okay, and if both enzyme and inhibitor bind simultaneously with the enzyme molecule, it means there is no effect with the affinity of enzyme and substrate and with the affinity of enzyme plus inhibitor. It means the binding of inhibitor does not affect the binding of substrate. Okay, it means there is no change in the affinity of enzyme with the substrate molecule, or you can say when enzyme and substrate bind, then they have not affect the binding of inhibitor. Okay, so students, let's understand what is this non-competitive inhibition. Okay, now, so students, suppose that it is an enzyme molecule and we have substrate and we have inhibitor. Okay, so this enzyme molecule bind simultaneously with this substrate and inhibitor both. Okay, so it forms enzyme substrate and inhibitor complex. Okay, enzyme substrate inhibitor complex. Okay, now students, let's understand this overall process by using a figure. Okay, now let me draw here. Okay, now students, suppose that this is an enzyme molecule and this are two sides. Okay, so here substrate, suppose that this is substrate. Okay, and now we have inhibitor. This is inhibitor. Got it? So substrate and inhibitor simultaneously bind to their respective site. Okay, and why it is called non-competitive inhibition? Because there is no competition between the substrate and inhibitor, because the binding site of substrate is different and the binding site of inhibitor is different. So substrate bind here and inhibitor bind here, and they forms a enzyme substrate inhibitor complex. Okay, this is the substrate. Okay, this is the inhibitor and the forms enzyme substrate inhibitor complex. This is enzyme substrate and inhibitor complex. Got it? So student, when enzyme substrate inhibitor complex is formed, then the reaction of an enzymatic, the velocity of an enzymatic reaction is decreases. So here a dead end create, dead end create. So there is no further enzymatic reaction is observed. Now students, as I told you, the binding of substrate and the binding of inhibitor takes place at different site. It means the binding site, the affinity of enzyme with the substrate is not affected by the inhibitor, and the binding of inhibitor does not affect the binding of substrate with the enzyme. Okay, so it means in both the cases the Km remains same, Km remains same, but binding of inhibitor decreases the Vmax. Okay, maximum velocity is decreases due to the binding of inhibitor. Okay, and Km remains same, it means affinity of the enzyme with the substrate remains same. Okay, as I told you, Km is inversely proportional to affinity. Km is inversely proportional to affinity. It means if Km decreases, affinity increases. Affinity increases, and if Km increases, it means affinity decreases, and if Km remains same, it means there is no change of affinity. There is no change of affinity of enzyme with the substrate. So here, due to the different binding site, the binding of inhibitor does not affect the binding of substrate, and binding of substrate does not affect the binding of inhibitor. Okay, now, so students, let's draw Michaelis-Menten equation and Landwehr-Burke plot for non-competitive inhibition. Okay, one point. Students, the non-competitive inhibition, the enzymatic reaction does not overcome by increasing the substrate concentration, because the binding of substrate and the binding of inhibitor takes place at different site. Okay, so if we increase the substrate concentration, then it binds to its own site, but it does not affect the binding of inhibitor. So non-competitive inhibition cannot be overcome by increasing the substrate concentration. Okay, now let's draw the graph of non-competitive inhibition in Michaelis-Menten equation and in Landwehr-Burke plot. Okay, let's draw this. So students, suppose that first we are going to draw for Michaelis-Menten equation. Okay, now students, suppose this is the enzymatic reaction without inhibitor, okay, this is the enzymatic reaction without inhibitor, and this is the Vmax. Okay, and student, as I told you, the Km is the half of the Vmax. Okay, or you can say the Km is that substrate concentration at which the maximum velocity is half of its velocity. Okay, so here suppose that this is the Km. Okay, so this is the Km. Okay, got it? And this is the half of the Vmax. Okay, now this is the velocity of the reaction. This is the increasing substrate concentration. Okay. Now, students, what if inhibitor is present? Okay. So as I told you, there is no effect in the Km, but Vmax is it decreases. Okay. So here this is okay. So you can observe that this is the enzymatic reaction in the presence of inhibitor. Okay. So you can observe that without inhibitor the Km is this, and with the inhibitor the Km is also at the same intercept. So there is no change in the Km, but enzymatic reaction, or you can say Vmax, is decreases from this point to this point. Vmax is decreases. Okay. So Vmax decreases. So if we again increase the concentration, suppose that we are again increasing the concentration, so again Vmax remains same, but Vmax Km remains same, but Vmax again decreases. Okay. And if you further increase the inhibitor, so again the Km remains same, but the Vmax is decreases. Okay, students. So as we increase the concentration of inhibitor, okay, this is the inhibitor, increasing order of inhibitor. Okay. So Vmax decreases, but the Km remain same. Okay, friends. So this is the graph for the Maclaurin equation in non-competitive inhibition. Okay. Now let's draw the graph of non-competitive inhibition in Landweber-Burke plot. Okay. Let's draw this. So students, let's draw the graph in Landweber-Burke plot. Okay. So suppose that students, this is y-axis and this is, let me draw this, this is the x-axis. Okay, this is x-axis. Got it? Now student, this is the point of interception. Got it? Now student, as I told you, in Landweber-Burke plot, if we move in right-handed direction, then Km increases, it means affinity decreases, and if we are moving in a left-handed direction, then Km decreases, it means affinity increases. Okay. And in y-axis direction, if we move in upward direction, then Vmax decreases, and in downward direction Vmax increases. Okay. So now let's draw the graph. So student, in first we are going to represent the enzymatic reaction without inhibitor. Okay. So suppose that this is the enzymatic inhibition without inhibitor. Okay. But this is the minus 1 by Km, this is 1 by Vmax. Okay. This is the increasing substrate concentration, this is the Km, this is the velocity of the reaction, and slope represent Km by V max. Okay, Km by V max. Okay, now, so students, as I told you, in non-competitive inhibition the Km remains same, but the value of V max decreases. It means now this line is shifted towards up, but the point is remains same. Okay, so here the graph is something like this. Km remains same, so graph is here. Okay, this is in the presence of inhibitor. So you can observe that in both the cases there is no change in the Km, but Vmax shifted from this point to this point. It means now the Vmax is here, so Vmax is decreases. Okay students, so this is about the non-competitive inhibition in Landweber-Burke plot. Okay, so students, this is about the non-competitive inhibition. Okay friends, so friends, if you like this video, then please share this video with your friends. Please do subscribe our channel, and friends, please don't forget to press the bell icon, so next time when we upload a new video you will get the notification. Okay friends, so friends, thank you very much for your patience, full hearing. Have a nice day.